I'm Chris. Are you psyched to learn about vectors? Good, me too. Okay, so in this physics lesson we're going to take an introductory look at vectors. This is just going to be part one. If you just watch it on the playlist or if you watch the suggested videos, you'll also see the additional parts that cover some of the more advanced concepts of vectors. But for right now, let's get a quick introduction to what a vector is. So many of you have probably already heard the term speed and the term velocity already introduced in your physics class. And the biggest difference between speed and velocity is that velocity has direction. Direction matters when you're dealing with velocity. And with vectors, direction also matters, and we're going to start to incorporate horizontal and vertical components of a vector so that we can look at vector addition and talk about what happens if you travel on a trip in a certain direction and then you change not just north versus south or east versus west, but if you change at a specific angle and then move another leg of the trip and then change another angle and move another leg of the trip. As you change angle, vector addition is going to become very important. So that's really where we're going to utilize our knowledge of vectors. So for an introductory look, a vector looks something like this. So we've got a head and a tail. Essentially it looks like an arrow, where when you shoot an arrow, the part that is the pointy end is going to be the head of your vector, and then the tail is going to be sort of where you start from. So I like to imagine it kind of like as if it were a shooting star or something like that, leaving a tail of dust behind it. So with your vector, you're going to have something called magnitude, and magnitude just means that it's the numerical value of the length of the vector, or another way of saying that is it's the scalar quantity, which means it's only the number, the direction doesn't matter. So when you talk about magnitude, let's say this vector, for example, had a magnitude of, we'll say 4 for this vector. And that magnitude is going to be directed in a particular direction. So for the vector, you would say you have a vector with a magnitude of 4, and it's looks to be, if you were to look at this in terms of your directions, north, south, east, and west, it looks like this is going somewhere in between north, which would be straight up, and east, which would be to the right. So this would be a vector of magnitude 4 that is traveling in the northeast direction, and when given an angle value, you would be able to know specifically exactly what portion of the northeast direction you're traveling in. So with a vector of magnitude of 4 in the northeast direction, you could be told that maybe it's traveling 30 degrees north of east, or you could be told that it's traveling 28 degrees north of east, or 42 degrees north of east, or 63 degrees north of east. These values just tell you that's kind of northeast, that's kind of northeast, that's kind of northeast, that's kind of northeast. So the different angle values will tell you exactly how much in the northeasterly direction your particular vector is moving. So the vector itself is what we see here in blue. It's just an arrow. And to describe the vector, you're going to be given a magnitude, which we see here is represented with the number 4, and you're going to be given both a direction and an angle. So for this particular vector, we would phrase this one as 30 degrees north of east. So that's it for a quick introduction to some of the terminology that we'll see with vectors. You've got head, tail, magnitude, and then direction and angle will be the additional components that describe what direction your vector is headed in. In part 2, which you'll see the link for in the bottom of the screen, but in part 2, you'll be able to take a look more specifically at how to tell the difference between something that's 30 degrees north of east versus 30 degrees east of north, and we'll make that distinction in the second part of our video series on vectors. Thanks for watching.